Okay, this is day 4 of chapter 3. Well, I think it'd be a good one to put on video here. So what we're going to do is we're going to try to figure out how to do something really simple. How to get the least squares regression line off of a calculator, off of a chart that you might see, or off of data that you might be provided. So off of a calculator, which is the most common, off of a chart, or off of data that you might just have, okay? Remember, least squares, what that means is this is the best prediction line that we have for a set of data that appears to be linear. And it's the best because the sum of the squared residuals is the least it could possibly be. That's explained in other lessons. Okay, so this right here, you should pause the video and you should go ahead and write this down. This is the procedure for how to calculate this in your calculator. We're going to use StatCalc 8 on the calculator. And I'll be showing you all of that, okay? And then if it's on a chart, what they do is they list the Y-Intercept, and the Y-Intercept in stats is called A, and the slope in statistics is called B. That's a little different because you guys are used to y equals mx plus b, where m is the slope and b is the y-intercept. In stats, we use a and b for y-intercept and slope. That's a little bit different. You'll see that on the calculator, okay? Now, there is a way to get the equation of the least squares line if they give you some data, okay? A couple things to point out. There is a formula. I have it written right here, but I'm going to rewrite it right here. The slope is the correlation, which is R, how correlated things are, times S sub y over S sub x. We know that slope is change in y over change in x. We've learned that. We learned that slope is y1 minus y2 over x1 minus x2. This is just another variation in the slope formula that you've learned in the past, where you have y over x, but in terms of standard deviation, multiplied by how correlated they are, okay? And we're going to do a problem like that here. So get this written down, pause the video, get that written down, and it's all going to come into play soon. Okay, let's handle these 6 problems, okay? From the data provided, write the least squares line. So in A and B, we're going to use a calculator. In C and D, we're going to use a chart that could be given, okay? And then in E and F, we're going to do some calculations, okay? So let's start with A. This is pretty simple. So what I'm going to do is I'm going to go to my calculator and I'm going to type in x into L1 and y into L2, and I'm going to help you set a few things up, okay? Okay, so I have typed in the x's into L1 and the y's into L2. Now, a couple things I'm going to do right now. Okay, so let me go back up so you can see all that I did. Okay, I'm not going to sort them because sorting them will mess up the ordered pairs because they're ordered pairs. This is bivariate data. Bivariate, meaning we have 2 pieces of data to explain one item on a scatter plot, okay? I don't have any context to question A. I have no context. All right, so first thing I'm going to do is I'm going to go second catalog. That's the 0 button. Second catalog. That's a 0 button. And I'm going to scroll down until I see diagnostic on. Diagnostic on will turn on R and R squared. So do that till it says done. All right. Then you're going to do this. Go to Y equals real quick and clear out everything out of there. And second Y equals, and go ahead and turn all your scatter plots off. That's a good starting point to start with. You don't necessarily have to do that, but I like to do that. Okay. I'm going to go stat. I'm going to arrow over to calculate, and I'm going to go down to number 8. Stat calc 8. And I'm going to tell it I want L1 to be the X and L2 to be the Y. And that's all I'm going to do. The other stuff, just leave it alone. And hit calculate. Now on your calculator, you may end up doing L1 comma L2. L1 comma L2. It may be, like I said, L1 comma L2. That might be how you have to do it on your calculator to get the line, okay? All right, and then I'm going to go ahead and hit calculate. All right, now I've gotten A and B, R squared and R, okay? A is the Y-intercept. B is the slope. So this equation is Y hat equals, and I'm going to round in no particular place, 1.66 plus 0.525x. And that is my equation for the best fitting line for that data. Now, we didn't graph the data. If you graphed it, you would see this line passing right through pretty much all those points. That's going to happen on another lesson, okay? All right. Now, let's go ahead and do question B. So here's the prompt for B, and this has context, okay? This is millions spent on education and millions spent on prisons. As you notice, the more you spend on education, the less you end up spending on prisons, okay? This has a negative slope. This is a really common political point that educators and politicians point out. The more money we pump into education, the less we end up having to pump into prisons later. It's a common set of data that I thought I'd show you. And this is in millions. So as you can see, the answer is 12.6 million minus 0.661 times million spent on education. So for every million you spend on education, you will spend 0.661 millions less on prisons. That's how this reads. Although the reading of this, we're not really worried about today. Today we're just worried about getting these things, getting the line itself, okay? So I'm going to go ahead and put these into L1, this into L2, and do the same thing and see if I can get this line with this particular R. Okay, so I'm going to go stat edit, and I'm going to clear L2, and I'm going to clear L1. And then I'm going to type those in. Okay, 2.1. And this takes a while here. You can work along with me, which would be great. Okay, now I'm going to go over and type in L2, which is the Y's. so I got those all typed in. Then I'm gonna go second quit. I'm gonna go stat, calc, and this time I'm gonna scroll down to number 8. There's all kinds of regression analyses you can do, but we use number 8 for lines, linear regression, A plus BX. I'm gonna hit enter. This is where you are probably gonna type in L1, comma L2, probably on your calculator. L1, comma L2. Although you might have mine, I'm not really sure. Okay? So I'm going to slide down to calculate. And there we go. Okay? And as you can see, that matches what we had on the answer key. 12.6 million minus 0.661 times x. Okay? So you can go back to the answer key, and you can see how I got that. All right? So there you have it. Okay, that is a really easy way to do this. Okay, so that's simple, how to find the line off a calculator. It's even easier to find the line when they give you things. They have this thing called coefficient, and there's going to be a bunch of more information here later. But for right now, it's easy. Okay, so and the constant is the y-intercept, and this is the slope. So all you're going to do is write down A and B. This is A, and this is B. This is A, and this is B. So this is incredibly simple. We're just going to write down this plus 938.4 and put an X. And by the way, you always have a hat, because Y hat means the predicted Y. Okay, that's why there's a hat here. Predicted amount of money spent on prisons in millions. That symbol needs to be there to be mathematically correct. Okay, and as you can see on this one, predicted murder rate is 0.3 plus 0.05 times ice cream sales. A strange correlation that we can go into some other time. Okay, real easy. All right, now let me slide up the next ones. The next ones have some calculations involved in E and F. Okay. So for E and F, they give you the average of the x's and the average of the y's, and they give you the correlation and also the standard deviations. And we're trying to find this particular line, okay? And this takes a little bit of work, okay? What you're going to do is you got to remember that formula. B equals the correlation times S sub y over S sub x. Now, to get that slope, we have the correlation. That is 0.9. And you're going to multiply that by the standard deviations of the y's over the standard deviation of the x's. Parentheses there. Okay. Now, once you multiply that, you're going to get the slope. And that slope ended up being 1.26. That ended up being the slope, 1.26. So this is 1.26. You should stop the video and verify that on your own. That's 1.26. Then the next step after you got the slope is you have to figure out what the y-intercept is. There's a lot of things you can do. Point slope formula, I have some of that here, but it's pretty easy to do. One of the things you've got to remember in any least squares line, there is one point that is guaranteed to be on that line. That point is the average of the x's called x bar, and the average of the y's called y bar. X bar, y bar will always be a point on the least squares line. Okay? So what you're going to do with that knowledge is you're going to set up this equation. Y equals, right, A plus, now we got B, 1.26, X, okay? Now, do we have a point to put in for xy? Absolutely. X bar, y bar. And that is right here, the mean of the x's and the mean of the y's. So I'm going to write in 4.7 equals a plus 1.26 times x, 3.2. And again, stop the video and verify the fact that when you solve for a using algebra, you will get 0.668. And then you will have found the equation. Okay, I'm going to do the other one now too. So if you need to pause the video, great. Go ahead and pause it so you can figure that out. Okay, for f, we got the means of the x's, the means of the y's, and we got the standard deviation. And this is a correlation between as temperature rises, ice cream sales go up. Makes sense, okay? So the first thing we're going to do is we're going to try to find the slope. And if you remember again, the slope is r times s sub y over s sub x, okay? So I'm going to take my slope, I'm going to multiply it by r, and then I'm going to have the standard deviations of the y's, which is the ice cream sales, 83.2, and the x's, the temperature, okay? And if you get that, you will figure out that the slope b is 10.4. So I would take a second to calculate that to make sure you can get 10.4. All right, now, once we got 10.4, we need to figure out what a is, the y-intercept. We know the answer is negative 580. A is. And we're going to use this formula, y equals a plus bx. Now, do I have a coordinate xy? I do. It's the mean of the x's and the mean of the y's. So I'm going to get in there 210.4 equals a plus b times x, 76. Okay? And then if you solve for a, you'll get negative 580. And again, go ahead and stop the video and calculate that to make sure that you've got that. Okay? So that is how you do E and F. So we've done 3 ways to get the equation. Calculator, chart, and giving certain statistics. You can always get the least squares regression line, or the best prediction line for the set of data that you have. Okay, we're going to go on to item 2, and we're going to be talking about interpolation and extrapolation. All right, really easy. Interpolation is when you predict within a model. And if you do interpolation within a model, it's considered pretty trustworthy because you have a model that is designed to fit a certain domain. Extrapolation is what we all love to do. Have a model and try to predict what's coming next or what's coming way in the future. Very, very tricky to do. Global warming uses a lot of extrapolation, although I'm not questioning its veracity, but it talks about what will happen by certain years if the trend continues. That is extrapolation, and you can question it. Diseases that break out. Figuring out what will happen the next week, the week after, that's extrapolation. Although it's very important to build models to predict, you have to understand that it is extrapolation, okay? And so extrapolation is less trustworthy, although we need to be able to extrapolate to try to predict what can happen. But we're just learning 2 basic words. Interpolation, using a model within the domain of study. This is more reliable. And extrapolation, using the model beyond the domain of study, and it's less reliable, okay? So, let me move the screen up. Okay, so if you were to type this into L1 and this into L2 and get the line, I will not do that now. you'll get this line. Y hat equals 15.23, that's the y-intercept, minus 0.623x, that's the slope, okay? And if you wanted to find the prediction for 15, okay, and you're going to ask yourself, is 15 within this data set? Well, this data set goes from 3 to 16. So 15 is definitely within the data set. This would be called interpolation. And how you would predict for 15 would be simple. You would put the prediction for 15, called y hat, will be 15.23 minus 0.623 times x, and the x is 15. Again, if you want to go ahead and calculate that, you will get around 5.885. And that's considered interpolation because 15 is within the data set. Now, how about predicting for something that's 20? 20 is 4 units above the max. So this is definitely extrapolation. And we're not sure if the trend's going to hold all the way to 20. So you're taking a guess on this. It's called extrapolation. But we can still get a prediction. And that prediction will be simple. Y hat's the prediction will be 15.23 minus 0.623 times 20. And if you calculate that, you will get around 2.77. Okay? Now the same thing goes here. I will do less this time. The same thing goes here. This is the year and the average temperature. This is your classic global warming. This data is actually from, I think it's from the Santa Ana courthouse. So you can see that over time, the average temperature in that area has gone up. Most people think it's because of all the cement that's been built around the Santa Ana courthouse over the years when it used to be more agrarian, way back in the 50s, more grass, etc. Okay. So again, you would type these into L1 and this into L2. A caution if you're doing this, I think I typed in 53, 61, 69, 88, 95, 100, 111, and 115, I think. I'm not sure I put the whole year, but nonetheless, okay? If you wanted to find the prediction for the year 2050, 2050 is 35 years after this trend. It is definitely extrapolation, but you could definitely put in the number 150, I think, goes in there, and you could get the predicted temperature. Okay, and if you wanted to do 1975, well, 1975 is right here. That's right in the middle of that trend. I would trust this to be perfect, and that would be interpolation because it's within the domain of study. And again, if you type in the correct number into the year code there, you'll get that answer. Okay? All right, that is day 4 of chapter 3. That's our video lesson. Hope you enjoy it.